All right, we're looking at 7.3, solve and write subtraction equations, starting on page 535. So the first thing that we look at, it says to scan the lesson and predict 2 things that you'll learn about solving and writing subtraction equations. If you scan through the lesson, you'll see that it talks about solving an equation by adding, and then the addition property of equality. When we look at our real-world link, it says that Megan's bowling score was 39 points less than Carmen's. Megan's score was 109. So I'd like you to do 1, 2, and 3 and pause the video now. All right, so it says that Megan's bowling score was 39 points less than Charmaine's. So I immediately figured this out to be Megan's score is equal to 39 less than Charmaine's. Now remember that less than is a subtraction and we flip the order. Then it says that Megan's score is 109. So for Megan, I can put in the 109. Down here for number 1, it went straight to it. It gave us all the information right here. That 39 points less than Charmaine's score is equal to 109. So we have to look at our keywords here. The less than tells us to subtract and flip the order, and we don't know what Charmaine's score is, so we're going to use C minus 39 equals 109. If we're using the number line, we're going to go ahead and instead to count forward. I counted forward by going by tens. I count by tens, and I skip counted by 9. So skip count by 10 puts me to 119, 129, 139, and then when I add 9 more, I'm at 148. So 148 is my answer. And then what operation does counting forward suggest? And that was addition. All right, so I want you to draw this because it's really important that you see how a minus and a plus work together. So addition and subtraction are inverse operations. So you can solve a subtraction equation by adding. So if we were at negative 3, and we were to add 3 to that, we'd move, because when we move forward, remember that that's adding, we go 1, 2, 3, and notice where that puts us, at 0. And remember that if we have something like x minus 3 equals 6, and we do our t-chart, that we want to do the inverse operation, which is add 3. Because, and like I show here, if we start at negative 3, and we add 3, we end up at 0, which means this is gone. And we're left with just the x, and then we would add 3 to the other side, and we would get 9. Then we check our work. 9 minus 3 equals 6. That's a check mark. So our answer is x would be 9 in this situation. All right. So number 1 says solve x minus 2 equals 3 and check your solution. So method 1 is using models. So it's saying that if we have this whole thing is x and we take away 2 and this portion right here is 3, then what is the whole thing, the x, the entire thing equal to? Well, obviously, if we have 5 and we take away 2, we get 3. That's kind of like one of those, what, minus 2 equals 3? Kindergarten kind of style deals. But remember that that's not what this is all about anymore. We're not doing kindergarten style anymore. We're not in 7.1. We're in 7.3, and we are going to use the t-chart. So method 2, because I'm sure that you guys probably aren't going to draw out these pictures all the time. Method 2 shows that we take the equation x minus 2 equals 3. We're going to make the lovely t-chart through the equal sign. Give yourself 1 line to do work. We're going to, let's see, we need to do the inverse operation. So I'm trying to change color here. We're going to do the inverse operation. Remember that our goal is to get the variable x by itself. So that means I need to get rid of my negative 2, my minus 2. And so if I do the inverse operation and I add 2, because addition is the opposite of subtraction, I showed you already on the number line that that makes the minus 2 go away. And what I do to one side, I have to do to the other. I can't just add 2 on one side of the scale and not the other side of the scale. I'm not going to be in balance. So I'm left with x on this side equals, and then 3 plus 2 is 5. And always checking our work. We're always going to check our work, guys. And don't just write it. Don't just put, oh yeah, 5 minus 2 equals 3, check mark, because it's not going to help you. If you don't really figure out what 5 minus 2 is and that equals 3, then you're just wasting time. You're not making it worth your time. You're going to write it anyway, might as well figure it out. So 5 minus 2 is 3, check mark. All right, you need to do A, B, and C on your own. Make sure that you check your solution and circle your answer. All right, guys, go ahead and pause now, and we'll be right back. All right, guys, so let's check the answers for A, B, and C with my answers here. You can see my work. You can see exactly how I showed my T-chart and how I checked my work on the bottom. Notice that I circled my answer. My answer is in the yellow circle, not the check mark down here. So it's really important that you circle your answer, because otherwise there's just a lot of stuff going on. Or if you need more time, pause the video. All right, addition property of equality says that if you add the same number to each side of the equation, the two sides remain equal. So just like a scale, if I have 5 apples on one, 5 apples on the other, and I add 3 apples to both sides, I'm still balanced. So that's what we're looking at here with the numbers, is that if we have 5 equals 5, we know that's true. We add 3 to both sides, 8 equals 8, we're still good. So that's why it's okay in algebra to do the same thing where we add 2 to both sides. We're keeping it balanced. So when you solve an equation by adding the same number to each side of the equation, you're using the addition property of equality. So number 2 says, at age 25, German Titov of Russia was the youngest person to travel into space. This is 52 years less than the oldest person to travel in space, John Glenn. How old was John Glenn? Write and solve a subtraction equation. So they've showed it in words, they've showed it with, and they've identified their variable, they showed this model, and then they've got the actual equation. I'm just going to talk through the actual equation really quick. So we already know that this kid's 25 years old, this guy's 25 years old, and that this, being the 25 years old, is 52 years less than the oldest person, John Glenn. So I know that less than means subtract and flip the order. I know the thing I don't know is John Glenn's age, and so we're using A for age, and that this represents that Titov guy, or Titov, and that's 25. So 25 equals A minus 52. And so if we want to figure out how old John Glenn is, we solve for A. When we do that, we're going to set up our T-chart, and we're going to add 52 to both sides. And so we end up with A by itself equals, and that's 77 years old. So John Glenn traveled to space at 77 years old. And makes sense. I mean, we're talking about a kid at 25 that's 52 years less than the oldest person, and 77 is definitely an older person, right? We can check our work by plugging it back into the original equation of A minus 52. If we had 77 minus 52, our answer is 25. Check. And notice how I did this, because this is how I do subtraction, not sideways. All right, so you're doing D. When you come back, we'll go over your answer. All right, so Georgia's height is 4 inches less than Sienna's height, and Georgia is 58 inches tall. So write and solve a subtraction equation, which means that there better be a subtraction sign in my equation. Excuse me. To find Sienna's height. So I'm using S for Sienna's height. I was originally using G for Georgia's height, but then we found out that Georgia's 58 inches tall. So now I can substitute in the 58 for the G, and when it says less than, it's subtraction with the flipping. And so it's going to be s minus 4 equals 58, or 58 equals s minus 4. Either one is true. S is going to be 62 inches. And when I checked my work, I did 62 minus 4 is 58, check mark. All right, example number 3 says Raheem's rollerblades cost $70.25 less than his bicycle. His rollerblades cost $43.50. How much did his bicycle cost? Write and solve a subtraction equation. So we're writing and we're solving. There's two things going on here, two things I'm going to be checking for whenever it comes to answers like this. So the first is that we know that the rollerblades cost $70.25 less than his bike. Okay? Then we find out that the rollerblades cost $43. So we know that $43.50 is the cost of the rollerblades. And so the first thing I'm thinking is less than means subtract. So I'm going to flip the order. The bicycle minus $7.25 is going to equal the rollerblades, which was $43.50. And we're trying to find out how much his bike is. So this is the first step. This is our first part of our answer. Then we need to fix our t-chart up and add $70.25 to both sides of the equation. So we get rid of the minus $7.50 or $70.25 and we move it to the other side by addition. So we're left with just B equals, and then 75. Oh, $103.75 is the cost of the bike. Oh, nope, I forgot to do a 1 here. Sorry. 4 plus 7 is 11, my bad. So $113.75. 113.75. I would have figured out that I made a mistake in just a minute whenever I checked my work. So I'm going to come over and check my work. Remember, this is my answer. So it's B minus $70.25. I'm going to subtract that. And we get $43.50, which is the price of the rollerblades. So we checked our work. So those T-charts keep things in a nice clear order. All right, so how is solving an addition equation different from solving a subtraction equation? So we've got an addition equation where it's like x plus 3 equals 6. And then we have a subtraction problem, which is like x minus 3 equals 5. And they're trying to say what's the difference between the two. So I want you to pause for a minute and think about that. Think about how you would answer a question like that. Okay, in my opinion, the way that I would answer that would be that for an addition problem, I'm going to subtract to solve. And for a subtraction problem, I'm going to add to solve. So that's the biggest thing that I see the difference is between solving an addition equation and a subtraction equation is that it's two different operations, two different inverse operations. Okay, we've got addition goes to subtraction, we've got subtraction goes to addition. All right, and that ends our 7.3 lesson on solving and writing subtraction equations. I'll see you in school.